Yes, our company have designed a multiple use platform. That's JJ Campbell and Associates, and we are working together with a research institution called Credit Centre for Renewable Energy in the Dundalk Institute of Technology in Ireland. Dundalk is about 100 kilometres north of Dublin, and we have uh, we have developed this platform with a view to harvesting wave and wind energy. The wave energy is through oscillating water technology, which is well known, and the wind energy using wind turbines, which are also well known. And we are working with the Centre for Renewable Energy in the tank testing and through the process from TRL1, Technical Readiness Level 1, to Technical Readiness Level 3, which we've completed. We've worked with personnel from Credit, and we have looked at the platform itself from the point of view initially and fundamentally of survivability in the very strong waves of the Atlantic coast, western seaboard of Europe. And having approached it from the survivability point of view, we believe that that's important because there has been some failures in particular wave energy, which probably are caused by not taking this sufficiently into account. Well, in the first instance, we set out to develop wave energy converter technology. Back in 2001, we applied to the Department of Marine in Ireland, where there was a breakwater being constructed off the west coast, a place called Rossaville, and we suggested that they start trialling wave energy by putting an oscillating water column in a concrete caisson as part of that breakwater, which was going to be built anyway, and by instrumenting it and starting a testing process with the university adjacent in Galway, that this would be a useful move in terms of helping Ireland to develop some expertise in that area. Unfortunately, they weren't convinced and it didn't happen. But something similar happened in Mitriku in the Basque Country in the north of Spain. And we kept an interest in it, but our core business was structural and civil engineering, and there was a massive construction boom in Ireland, which halted abruptly in 2008. So whereas we didn't have that much time for the wave energy considerations in the period up to 2008, we had a lot of time afterwards. So we got involved in that, and we as I had said earlier, we based our proposals on a large platform that would survive in the sea with the oscillating water column, multiple oscillating water columns, and we applied for grants to the Sustainable Energy Ireland. That's the Irish Renewable Energy Centre, and we got the grants, and we have gone through four. We've received four grants at this stage, and that's since 2008, and we have completed the TRL3 process, which is just proof of concept up to the TRL3, and we're looking to advance to TRL4 and 5 over the next 2 years, and then on to TRL6 as a pilot, and to the TRL 7, 8, and 9, and to commercial proposal. So we were developing wave energy, but wave energy at the level we were capturing wave energy wouldn't be economic on its own. So we decided to use on the floating offshore platform wind turbines, which are standard and proven technology. You have wind turbines now of 8 megawatts, which is huge, and we think by the time we get to commercial deployment in over the next 15 years or so, that they will be significantly bigger. And because onshore wind is causing some problems for communities, and there's the problem of the wind not always not being constant. We are and having to store electricity if you want to take a full advantage of the wind. That's not necessary offshore because you have the wind and wave coming together. The wind is never the same at the same time as the wave, so you have a phasing issue, and it's possible to provide a smoother delivery of power to the grid. That's why we're putting the wind turbines on the wave energy device. Well, the platform is very significant structure. We have built one in 300 model, which we presented at the advisory session. Um, we will be working through one in 50 models testing, which we've done already. We're doing more of it currently. We'll be doing one in 10 testing, and we'll be doing one in 4 C trials before building a multiple use platform, in 2030, maybe 2035. So the platform is in a V shape. There are two legs, 300 meters long each. It's 420 meters at the back. So this is a very big structure. Pointed out that the Berlaymont building would fit in the wake of the and similarly a football stadium like Stade de France or other as well. So it's very big, and the technology used is the oscillating water column technology to capture the energy, either through a turbine on each chamber, 500 kilowatt turbine on 32 chambers, or else by manifolding the chamber. As the wave comes in, it pressurizes the air inside the chamber. The rising wave will create a positive pressure, pushing the air up. You can capture the air in a duct, the positive duct, and then the wave is falling. There's a negative duct, negative pressure suction, and you can put these pressures, direct them into these ducts, and then put a turbine between them, or you can have the turbine in the oscillating water column. So that's part of the testing procedure to see which is the most favorable. So the wind energy is taken off by standard wind turbines. The motions that would be induced, would be quite substantial, but because of the size of the structure, are able to be, there's no issue like about whether they'll overturn the platform or anything like that. And that every structure offshore has to have an anchor or a mooring, and we have a gravity-based mooring, which is very substantial in itself. It's going to be built onshore and floated out. Similarly, the platform that we're building is going to be built onshore in modular units and floated out with a concrete hull and steel superstructure. The advantages of why we're combining this are because we need to smooth the energy to the grid. We need to ensure that the wave and the wind will provide that smooth delivery. But there's significant advantages in having this offshore. Onshore wind technology, onshore wind turbines, the wind is not always present, and you need to have pump storage to take full advantage of it, storage of some kind. And the storage that's envisaged is, pumping, when there is a wind, pumping water up to the top of a mountain, which would be carved out, and then releasing this at night through turbines, standard turbines, which would provide energy in the off period. That's very, very expensive. You won't have to do that if you have the wind turbines offshore. Additional advantage is that there's more strength in the waves offshore, 40 to 50 kilometers offshore, and also the wind doesn't have obstructions like it has on land, so you can get higher wind speeds as well. So there's very significant advantages. Obviously, there are very, very significant problems as well in relation to resisting the huge forces that are in the Atlantic waves, and that's why the structure is so big, and that's why we have the wind turbines to work together, combine it. Yeah. Well, aside from the wind and the wave combination, there's also a possibility that because the structure is so big and the energy is taken out of the waves, which are incoming into that, behind this there is a very significant large still basin. So it's possible that aquacultural uses may be able to be used. In addition, there's a very big surface area, plan area to this large device, large platform, and photovoltaic might be a possibility as well. There's 12,000 square meters of just of the plan area. So as photovoltaic advances, it may be possible to use this platform for that as well. And you had asked why is it a good moment? Well, we're after the conference of the parties in relation to climate change in Paris, and the solving the problem of global warming and the dangers that are inherent in what's happening now are immediate. And there couldn't be a better moment. You know, there's a to a certain extent a race against time, which people would have regarded as alarmist 15 years ago, but not so now. And all the top climate scientists, like James Hansen that I mentioned earlier, they are making it absolutely clear that we're not talking about 2050. We're talking about 10 or 15 years' time. So we see that as renewable energy has to replace fossil fuels. And you can see that even the big polluters, many of them are becoming involved now, looking for possibilities of getting involved in the green technology, so called. So we think it's a good moment, and that the issues become more and more pressing, and that whether or not it's this technology that will solve the problem, it will have to be solved. As we've as always, you learn as you're engaged in the actual project from other projects. I mean, there's a checkered history to wave energy. There have been many promises and claims made which weren't always able to be actually defended. And the results are that investors may shy away from wave energy because of the claims that have been made and some failures. So we have been quite conservative in our approach and started from the survivability issue, which will reduce risk and so on. But obviously there are costs involved in that, and there's a levelized cost of energy that you're aiming for, reducing it as close as possible to offshore wind, onshore wind. But there's a compromise somewhere along the way. So lessons from the wave energy sector are pretty important ones. There have been many failures, and we don't want to go that road. We're learning today that there are companies who are combining aquaculture with offshore wind, and we have arranged meetings with a couple of those companies. So we expect to learn a bit more about that, and the combinations are, there are only a limited number of combinations you can make, but you could put a tidal stream current onto this platform as well. But the problem is that there are very few places, locations, where you would have the combination of suitable wind, wave, and tidal stream. But we look at whatever combinations are possible. I mentioned photovoltaic as a possibility, and aquaculture, and we're open to others as well as they come up. Yeah. But at the moment, wind and wave are enough for us. Yeah. We haven't really got to the users, the end users yet. There'll be, electricity users, and we have estimated and have had verification of that by the Maribe team, that this one of these platforms will provide 77 gigawatt hours annually in terms of electricity produced wind and wave, and that would provide the electricity requirements of about 21,000 houses in a year. So the people that we're dealing with now are the funding agencies. We have met with some investors at a high level. Uh, we have spoken with the National Treasury Management Association in Ireland, which is responsible for developing, for investing in potential commercial developments. We made a presentation to them. They were very happy with it, but they said that because of their mandate, we needed to be further up the TRL levels, closer to commercialisation, and that they would look certainly at us at pre-commercial and commercial levels. Similarly, a large American fund, the Carlyle Fund, we had met with one of the high-level people on the board there. They were interested as well, but again, the point was that we needed to be further along before they could get involved. So it's convincing the investors first, and the investors will convince the users. Well, we have to make the point that we're at TRL level 3, and we're a core structural and civil engineering expertise that we have in our company, and we, some of the people that we're working with in the research institution are people that individuals like the managing director John Campbell and myself were in college with. We have been interested in renewable energy for a long time, but we up to now, we get the testing done where there are expert testing facilities at University College Cork, Maribe Institute, and similarly in Dundalk, the Centre for Renewable Energy. So I have, and a couple of others have done some of the courses there, just to be familiar with the actual wave energy equations, so that you're aware like of what can be an advantage or a disadvantage. But farm out that. In terms of going forward, yes, we will have to have expertise, which is the structural and civil engineering aspects. We're happy enough that we can provide, and in relation to the oscillating water columns, we're fairly happy as well that we have good knowledge of that. But we are obviously in relation to turbines and valves and some of those things, we have ideas about them, but we're looking at the process of going through TRL4, what we plan now over the next 2 years, which is going to cost over 2 million. We will have to build a model. We built the first model ourselves. We're not the next one. Is going to be tendered out and built by a fabricator and so on, and it's going to be instrumented and everything by others under our direction and supervision, and it's going to be brought to the tank testing facility. Whereas earlier on, because of cost issues, we did all of that ourselves. But we have to now put it on a more professional basis, obviously. Yes, well, we got involved in the Maribe process through initially Sustainable Energy Ireland and the Mary Institute, the Beaufort Institute in Cork in Ireland, where there's a lot of experience. They have been tank testing there for quite a period. So it was suggested to us that we consider this, and we did, and we got involved with the Maribe team. We thought initially this was going to be, a couple of days, and we'd apply for something, but we began to realise that this was a more serious issue in terms of the things that we hadn't possibly considered adequately before, that we now had to deliver costs and so on in relation to them. And so we had initially an independent review of the testing process by Black and Veatch, who are an international maritime consultancy, and then the Maribe team in Cork, Swansea, which was about assessing the risks and so on, and the BVG company, which is expert on wind energy turbines, and the marketing people in Cork. We worked with them, and gradually we began to see the extent of the requirements that would be necessary to market this. We had never prioritised marketing previously because we were looking down the road quite a bit and saying we'll resolve that when we get there. But the question of it's with all wave energy devices, the initial steps are funded by maybe creative people who put their own resources into it and get small grants from the government. But once you reach TRL3, you're talking about millions to go further, and to go to a pilot, you're talking about 100 million. So it's impossible to actually continue as, if you like, an amateur setup. And we now understand that, and we have benefited enormously from the Maribe contact. Yes, we found it very beneficial. We've only had it's just over, and we've had a discussion about it, and we think that the questioning by experts is very important. You really have to. These are the questions that we appreciate that we have to answer. And they were all informed. There were no silly questions, and it wasn't a question of trying to expose us. They were asking questions that we are considering ourselves. We found that very useful. Thank you.